Hello, this is Paul.
And this is Yash.
And today we're going to do a show me on Junit theories. Okay, so here's our setup. Suppose we're defining some class, MyStuff, the MyStuff class. It could be anything, and it's got instance variables and constructors and methods and whatever, and we kind of don't care about that. All we really care about in this show me is that we've decided to override the equals method because we want a notion of logical equivalence between our objects. And I've also shown us overriding the hashcode method. So why did I also add that?
So according to Java docs, whenever we override equals, we are supposed to override hashcode as well.
That's right, and why is that important? If you don't do that, what will you not be able to do?
We will not be able to get like similarity in sets, like hash sets and
Yeah, so if you override equals and you don't override hashcode, then your MyStuff objects are not going to be suitable candidates for storing in any of the standard Java collection containers that happen to use hashing functions. Those containers just won't work properly. So Yash, if we go to the Java doc and look up the contract for the equals method just by itself, we're going to see that there are a bunch of general constraints it's supposed to satisfy. What do those constraints look like? What are some of those?
So equals has 4 properties. One is reflexive, second is symmetry,
Okay, keep going.
and third is transitive, and fourth is it should be consistent. So it means that like we are calling equals for first time, we get objects to be equal, then we should get equal after like we call them again.
Yeah, and there's actually a property about null values too.
If object passed null, then it should return false.
Yeah, so there are a bunch of general properties we're supposed to maintain just about equals. And then there's also a rule about equals and its relation to hashcode. And what is that rule?
So if two objects are equal, then their hash code is supposed to be equal. And
But that doesn't go the other way around. So if two
Yes.
objects have the same hashcode, they don't have to be equal.
yeah, true.
Okay, so let's see if we can capture some of those properties with the Junit theory. Okay, so for the rest of the show me, we're going to look at 2 specific theories. The first one here is just about hash code itself, and so that's the property that Yash just explained. And so this theory about hash being consistent with equals will have some assumptions and some assertions. Yash, what's an assumption?
Assumption is something we consider it to be true before we assert. So assumptions are basically preconditions.
That's right. So if the assumptions aren't satisfied, then the theory doesn't make any sense for those particular data objects. If they are satisfied, then we'll make some assumptions about them. So assumptions are preconditions, and assertions would then be what?
Postconditions.
Yeah, that's right. And then this other theory here, this will be one of the equals theories where we'll worry about symmetry for equals. And we're not going to look at the others. If you'd like to see some learning examples, they're on the book website, which is here, and you're welcome to go look at that.
I guess you have text if you want. Like you can just use text.
Yeah, that's probably better. Okay, Yash, I've got 2 parameters now, A and B, of type MyStuff. What's the assumption that we need?
So we will assume true that A dot equals B.
Assume true. A dot equals B. Okay, we need that. And what will our assertion be?
We will assert true that A dot hashcode equal B dot hashcode.
That's right. So let me put that in. So that's right. We've asserted that a.hashcode is the same as b.hashcode if a dot equals b. If a dot equals b is not true, then the assertion will not be evaluated. And so this is exactly what we want, except there's some problems here. So can you tell me some things that maybe aren't so good?
So what if A and B are null?
Okay, so if a is null, then when we do this dereference here on the a variable, we'll get a null pointer exception, and that's not good because the JUnit test will then fail.
Yes.
How could we take care of that?
We can assume not null, A and B.
That's true. We could have another precondition, assume true a not equal to null. Let me write that in. So if we put that assumption in before we do the assume true a dot equals b, then null values will not be a problem if they're parameters.
Yes.
Anything else to object to?
Assume true B is not null.
Well, we could do that, and that would certainly be a fine thing to add. Turns out that the equals contract never sends back a null pointer exception, so if b is null, that's fine.
Okay.
But you're right that it would be safer to assume b was not null as well.
Okay.
Any other things to look at here?
So parameters can be of type object. They should go like up the way to the hierarchy.
That's right. So this theory is fine the way it is. It's valid. But it's not as general as it could be, because it's not just mystuff objects that have to have hash consistent with equals. It's any objects.
Yes.
And so to make this more general, what I should really do is take these parameters out and replace both of those parameters with the type object, because then the theory is as general as it could be. So, cool. Let's try one more theory and see if we can get all the pieces right from the beginning. Okay, Yash, for the symmetry property, how many parameters should there be and of what type should they be?
So there should be two parameters, and both of them should be of type object.
That's right, and the reason is that object is defined in the, or equals is defined in the object class, and if you look at the Java doc for equals, that's where you'll see the contract. So we should put objects in as parameter. So now we're ready for some assumptions. So Yash, what do you think our first assumption ought to be?
So our first assumption should be that A is not equal to null.
That's
and
right.
B is not equal to null.
That's right. We want to take care of the null values so that if our theory ends up with some null values stuffed in, we don't have problems. So let me put those in. So since this happens all the time in JUnit theories, there's a special notation. So Yash, what's going on here?
So here we are assuming that A and B are not equal to null.
So that's a little faster than writing assume true A
Yes.
not null and assume true B not null. Okay, so do we need any other preconditions, or are we ready for a post condition?
We are ready for post condition.
So Yash, what do you think that post condition ought to be?
So whatever value A dot equals B has, B dot equals A should have the same value. So
That's exactly right. So that is exactly right. So whatever A dot equals B is, that should equal
Yeah.
B dot equals A. Well, let me write that in. So Yash, how does that look?
Yeah, it looks good.
That's true. So our theory is very general because we're using objects which are as general as possible, in this case all the way at the object class.
Yeah.
We're properly taking care of null values, and in every other circumstance, whatever the value of the equals method is in one direction, it has to match the value in the other. So true matches true, and false matches false, and that's all the cases. So that's the end of this JUnit theory. Thank you very much.